Welcome to 5.1 Part 2. So this Part 2 is simplifying and rewriting trig expressions. So once again, you can already read this and see the two examples that I gave you. So number 1, let's simplify this expression. Cosine of x is equal to tan of x plus cotangent. So the first thing I would do is rewrite in terms of sine and cosine. So I have cosine of x times, well, tan is sine over cosine. And cotangent is cosine over sine. Before I can add what's in my parentheses, I need to make sure they have a common denominator. So in order to do that, I'm going to multiply this by cosine x over cosine x. I'm going to multiply the left guy by sine x over sine x. So in rewriting, I'll have cosine of x times sine squared x plus cosine squared x over sine x cosine x. Okay, so I multiply these out, sine squared. So multiply these out, so I have sine times sine is sine squared, cosine times cosine is cosine squared, and then I'll have sine times cosine as a common denominator, so I put that on the numerator, the denominator. So one thing I noticed is like, hey, guess what? Sine plus cosine is equal to 1. That's a Pythagorean identity. So 1 over sine x, cosine x, and all of this is being multiplied by cosine x. Check it out. Cosine x cancels out. I'm left with 1 over sine of x. We can rewrite this as cosecant of x. So let's try out the next one. You can pause the video, give it a try. Alright, so first thing I'm going to do is rewrite things in terms of sine and cosine. Cotangent of x is cosine over sine. So really what this second term is equal to is cosine squared x over sine of x. Well, shoot, this left side is over 1 because we just have sine of x. So I want to have common denominators so I can actually add these together. So I'll multiply by sine of x over sine of x. That way we have sine x on the bottom. So sine x times sine x is sine squared x over sine x plus cosine squared x over sine x. The same thing as saying sine squared x plus cosine squared x all over sine of x. Well, shoot, this top part, cosine squared plus sine squared is equal to 1 over sine x. Well, hey, that's just the reciprocal identity of cosecant. Well, shoot, look at these two problems. It's the exact same thing. These two are the exact same problem. Pretty cool. Alright, so we're going to keep going. So number 3 is cosecant squared x over 1 plus tangent squared x. So the first thing I'm going to do is simplify the bottom. So what makes me do that? So the first two problems I simplified by getting everything in terms of cosine and sine. Because there really wasn't an identity. There wasn't anything I could pull out. Nothing I could factor out from both terms for number 1 and 2. But number 3, I see something interesting. I see this 1 plus tangent squared x. So to me, that rings a bell that says, hey, I can't really rewrite anything in terms of cosine and sine because I have this like to make things cancel out because I have this pesky 1 plus tangent squared x on the bottom. So that sucks. But that says to me 1 plus something squared must be Pythagorean. So which one is this? 1 plus tangent squared x. 1 plus tangent squared x. Let's see. I think, it's up here. 1 plus tangent squared x. Hey, right here. That's equal to secant. Okay. So of course you have your equation sheet with you. So the bottom is the same thing as secant squared of x. And the top is cosecant squared of x. So really to you, you should be having your equation sheet in front of you when you're working on these problems, because that's what you'll have on the test and quiz. I'm not making you memorize them. Okay, so now that I have everything like simplified out of Pythagorean, I see I just have like something squared on top divided by something squared on bottom. Can I rewrite these in terms of sine and cosine? Like I have to, otherwise there's no other way I could simplify. Because you don't want to, like, I could plug in cotangent squared x plus 1 for cosecant squared x, but like it's not going to get me anywhere. Instead, now that I have like a single term on top and a single term on bottom, I can put it in terms of sine and cosine. So, dividing by a fraction is the same as multiplying by the reciprocal. Here I was dividing by 1 over cosine squared, so I'll be multiplying by the reciprocal by cosine squared x over 1. So wait, that's just cosine squared x over sine squared x, which you know is cotangent squared x. Cosine over sine is cotangent, so cosine squared over sine squared is cotangent squared. Awesome. Alright, let's try this next one. So right away, I'm like, oh, I see something plus 1, right? But it's not squared. Well, shoot. What if I FOILed this out? It seems like that's the only way to do it. Nothing's squared. Can't really cancel anything out. So it's best to do FOIL. So first, secant x, cosecant x, outer plus secant x, inner minus cosecant x, tan x, minus tan x. Oh my god, this is ugly. Let's put everything in terms of cosine and sine, because here we have 3 different trig values. We have secant, we have cosecant, we have tangent, 3 specific functions. But if we put everything in terms of sine and cosine, maybe something will cancel out, like maybe there's some voodoo or something going on in these terms. We shall see. So secant is 1 over cosine times 1 over sine, yikes, plus 1 over sine minus 1 over, let's see, oops. Cosecant, I'm sorry, 1 over secant is 1 over cosine. Otherwise, okay, cool. 1 over cosecant is 1 over sine of x. Tangent is sine x over cosine x. And tan is sine x over cosine x. Oh my god, check this out. Sine x cancels out. Sweet. So I have 1 over cosine. Right, so this term goes to minus 1 over cosine x. And this term to the left is plus 1 over cosine x. So that stuff cancels each other out. It's kind of like if you have positive 1 and minus 1. Positive 1 minus 1 goes away. Okay, cool. So now I have 1 over cosine x, oops, sine x, minus sine x over cosine x. Because I only have these 2 terms left. Whew, alright, so we need to have a common denominator. Multiply by sine on top and bottom. Because now I have the same denominator. So I have 1 minus sine squared x over cosine x sine x. So this top part, 1 minus sine squared x, is the same thing as cosine squared x by the Pythagorean identity. And the bottom is cosine x sine x. So I know one of my cosines on the top will cancel out with the one on bottom. Oh wait, so then I just have cosine of x over sine of x. That's equal to cotangent of x. Cool. So we have 2 more problems. I'm trying not to go too fast, but I don't want to make these videos too long. I'll post the solutions. Definitely try these out and come to bonus and ask questions. So here, this just deals with looking at the Pythagorean identities, like cosine over sine is cotangent, cosine over sine is cotangent. Seeing that 1 minus sine squared is the Pythagorean, that helps out. Oh my god, I have 8 questions. Alright, number 5. Cotangent squared x plus 1 times secant squared x minus 1. Oh, well, let's see. Now I have something squared plus 1 and something squared minus 1. There's a good shot that my Pythagorean identities will be popping out right now. So pause the video, try this problem out yourself, and then we'll get back together in about 5 seconds. Alright, cotangent squared x plus 1. That guy is going to be cosecant squared x. That's what that is. Secant squared x minus 1. Secant squared x minus 1 is equal to tangent squared theta. Alright, so we simplified both terms. Now we just have, instead of having to FOIL everything, we just have these two terms being multiplied. Alright, two different trig functions, but if we write in terms of cosine and sine, I feel like something will cancel out. So this is a reciprocal of 1 over sine squared theta, and tangent squared theta is just sine squared over cosine squared. Check it out. So we have 1 over cosine squared theta. But we're not quite done. We can rewrite that as secant squared theta. Oops, I keep saying theta, I mean x. Here the x is the angle, so you're always checking, can you cancel anything out immediately? Can you factor anything out? Can you rewrite in terms of cosine and sine? And can you use Pythagorean identities? Alright, so for instance, this one. Tough crowd. So the first thing I can do is, I see this 1 plus secant x. Some people are very tempted to, like put in like tangent squared or like tangent or something like that. I know on the quiz some people would put like secant squared of x minus 1 on top and be like, oh, 1 minus secant cancels out. What I would do is I would multiply by 1 minus secant of x over 1 minus secant of x. This makes me have a difference of squares on the bottom. 1 plus tangent squared x plus secant of x over 1 minus secant squared x. So now I can use Pythagorean identity on the bottom. So typically, tangent of theta plus 1 is equal to secant squared theta. If I subtract secant from both sides, like if I put tangent on the right side and secant on the left, I have 1 minus secant squared theta x, secant squared x. Subtract from both sides. So it's on the left. And to get tangent to the right side, I have to subtract him. So it's going to be minus tangent squared x. So now I see 1 minus secant squared x is equal to negative tangent x. 1 plus tangent squared x over 1 minus, secant x over negative tangent squared x. That's going to be equal to, let's see, 1 plus, so tangent squared x goes away. So this will be plus, let's see, negative 1 minus secant of x. Distribute out the 1. It's 1 plus, let's see, negative 1 plus secant of x. So 1 plus a negative 1 is 0, so this is just going to be secant of x. If you want a more in-depth going through this problem, definitely check out Bonus or email me, set an appointment. I'm more than willing to meet with you, especially this one's a little hard. Seeing that you had to multiply by the conjugate, right, to make it a difference of squares so you can get 1 minus secant squared x, so you can use Pythagorean, like that takes practice, which is why I'm giving you the study guide is to practice. And then some people like making the connection. If you see a 1 and a squared, it might be a positive tan squared, it might be a negative tangent squared x. So that one's a little more difficult, but you got this. Here we go. Cosecant x, sine x plus cotangent squared x. Oof. Let's put everything in terms of sine and cosine. So this guy, cosecant, is the reciprocal of sine. So I have 1 over sine times sine x plus, what's going to happen to our sines? Cancels. Actually, let's hold the door for a sec. So 1 plus cotangent squared x. I feel like that's a Pythagorean identity. It is. 1 plus cotangent squared x is equal to cosecant squared x. Awesome. Whew, that was a close one. So if I would have gone and, like, it's only because I started rewriting things in terms of sine and cosine did I notice that it cancels out, and I'm like, wait, then I'll have a 1 plus cotangent squared x. I could have rewrote this in terms of sine and cosine. That would have been fine. Cosine squared x over sine squared x. Then I would have had 1 plus cosine squared x over sine squared x. I would have been like, oh, well, you know, this is actually the same thing as cotangent of x squared. And then I could do Pythagorean identity, rewrite 1 plus cotangent squared x as cosecant squared x, and I'll be done. So it's tricky. Number 8, cosine times 1 plus tangent squared x. Hold the door. 1 plus tangent squared x. That has to be a trig identity. Look at your equation sheet. Tangent squared theta plus 1 is actually secant squared theta. Sweet. So cosine, let's rewrite this in terms of cosine, right? Secant is the reciprocal of cosine. So this is 1 over cosine squared theta. One of these on the bottom will cancel out. 1 over cosine. Hey, that's just secant of x. Sweet. So that is all of part 1. I'll work on part 2 and upload the solutions later. Email me if you have questions. We also can meet. Good luck.